Hello chemists and welcome to today's episode of Bale's Chemistry. Today we're talking about bond enthalpies, which is on paper 1 and 2 of the AQA A Level exams and can be found on specification 1.4. If you're finding this video useful, we now have a playlist for all our energetics topics videos on our YouTube channel. So bond enthalpies is all about breaking and forming bonds. Breaking bonds is an endothermic process as energy has to go in to break the bonds apart, whereas forming bonds is an exothermic process as energy is released when atoms are joined together as bonds. So the bond enthalpy is defined as the enthalpy change required to break 1 mole of bonds under standard conditions. If we look at that in terms of a chemical reaction, we can take our reactant molecules, we can put some energy in to break them apart into separated atoms, and then we can join them back together, releasing energy to form our product molecules. This then can be shown as an overall delta H for the reaction, with the energy difference between our reactants and our products. So if we look at a simple chemical reaction where we're turning our reactants through into products, we want to be able to calculate the enthalpy of all the bonds broken and then the enthalpy of all the bonds formed. We can then use this equation, which is the enthalpy change equals bonds broken minus bonds formed, to work out the overall enthalpy change for the chemical reaction. This is an example of some of the data you might find in the exam question. You will always be given the data that you need to answer the question, so you don't need to remember it. So let's look at a simple example of burning ethanol in oxygen. We'll work out the bonds broken first. To do this, I like to draw out the molecules and work out all the bonds that we're going to break in the process. I then look through the exam question and find the data to go with those values and work out a total bonds broken. I then do exactly the same for the bonds formed. I like to lay the calculations out like this because it shows really clearly to the examiner all the calculations I've done to work out the total bonds broken and the total bonds formed before I put it into the equation. I then do bonds broken minus bonds formed and get a value of minus 1277 kilojoules per mole. So we're going to look at a slightly more complicated example now where we're looking at methane reacting with oxygen and we're given the overall enthalpy change for the reaction but asked to work out the bond enthalpy of the oxygen-hydrogen bond present in water. So we'll go through the calculation in exactly the same process as we did before, getting a total for bonds broken, and then we'll get to bonds formed. When we put in the values for bonds formed, we're going to have the value for the carbon double bond oxygen, but we don't have the value now for the oxygen hydrogen bond. So I'm going to put that in as X, so I'll have 4X there on the total side for bonds formed. Then we'll look at the equation that we're going to use, as always, bonds broken minus bonds formed, and we'll do a little bit of rearranging. So I've now taken the enthalpy change for the reaction over onto the right-hand side, and I've moved the bond enthalpy for OH onto the left-hand side as 4X. This gives me a total value of 1,856. In the next line of the equation, I'm going to divide that value by 4 to get 464. So the bond enthalpy for my OH is 464. I've divided it by 4 because, of course, there are 4 instances of the oxygen-hydrogen bond on the product side of this chemical reaction. So to try and get our calculations right every time, I've got 5 simple steps for you to go through. The first step is always draw out the structures. Drawing out the structures helps you make a good, clear list of all the bonds that you're going to break, and is definitely my #1 exam tip for this process. Step 2, identify all the bond enthalpy data in the question and add that next to a nice list of all the bonds that you're going to break. Step 3, calculate the total bonds broken. Make it really clear where you have calculated the total bonds broken. Step 4, now calculate the total bonds formed. Again, make it really clear where you calculate the value for total bonds formed. And step 5, plug the numbers into the equation, bonds broken minus bonds formed, to get you your overall delta H for the chemical reaction. So there's just one bit of extra information to take for this topic, and that's average bond enthalpies. The data values that we can look up in data books or given to us in exam questions are always an average of the bonds found in lots of different molecules. This means that the actual bond value that you might calculate from a chemical process will not be the same as the one listed in the book. It'll be very close, but it won't be exactly the same. And that's again because the bond enthalpy that's listed in the book is an average of all the different bonds in all different molecules. So let's take a recap from today's episode. Bond enthalpy is for breaking 1 mole of bonds. Breaking bonds is an endothermic process and making bonds is an exothermic process. Delta H equals bonds broken minus bonds formed is the equation that you need to remember, and that bond enthalpies are all averages. So the one that you might calculate might not be exactly the same, but it should be very close. I hope you found today's episode useful. If you have enjoyed the video, please hit the thumbs up. And for more videos about enthalpy changes and all the A-level chemistry syllabus, make sure you subscribe to the channel. Thanks for watching and have a great day.